Hey, you should see that in today's list of activities, I posted the second sprint from lesson 1 in this book. I want you to go ahead and pause the video and try that sprint real quick, and then I'm going to show you the answers as soon as you pause the video. Don't worry about if you can't like print out the sprint. Like you can just look at it on your screen and just write the answers on a separate piece of paper, right? You don't have to print everything out. I know it's a little more work to have to write it on a separate piece of paper, but we'll make do with what we got. All right, so you're pausing and doing that now. All right, so hopefully you're coming back from your video being paused and you're going to check your answers against the one that I just did. So it should be sprint B. And here's what I got. So you can go ahead and pause again for a second if you want to just check your answers. But I'm going to continue talking assuming that you just paused. So most of these should be getting fairly easy for you, especially these first few ones. Some that I want to point out to you is like number 12 and number 15. How 60% is written as 0.6, but 6% is written as 0.06. That sort of thing is confusing for some students. What else? I want you to get good at using like ratios and equivalencies in your head. For example, I did a little scratch work or maybe even use my calculator or whatever to figure out that 45% is 9/20ths. But then when I went to the next question, I didn't have to do all that work again because I immediately realized that 15 is 1/3 of 45. And so my fraction is going to have 1/3 in the numerator, right? What 3 is 1/3 of 9. So instead of 9/20ths, I got 3/20ths. And you can use those patterns a lot throughout these sheets. For example, here I did 6/10 is 60%. Well, 6/20ths, that's the same number of pieces, right? In 6/10 and 6/20ths, I have 6 pieces. But in 6/20ths, the pieces are twice as small, which means I have half as much stuff. So if I have 60% here, I should have half of that, which is 30% here. And then when I went on to 6/25ths and 6/50ths, that relationship is the same, right? Same number of pieces, but in 6/50ths, the pieces are twice as small. So I have a percent that should be twice as small, and half as big, sort of mean the same thing. Then you get to those ones where you have 75 in the denominator, and those are kind of tricky. To remind you of the best way I showed you how to do that last time was, let's say you have 6/75ths, and you want to change that so that it has 100 on the bottom. That's like your ultimate goal when it comes to percents. I'm off the screen. Well, it's hard to change 75 into 100 using multiplication or division. So instead, you change 75 to a number that is easy to make into 100, and we get there by dividing by 3 first. And so this fraction becomes 2/25ths. Oops. And now you multiply top and bottom by 4, and you get 8/100. So kind of a two-step process on that tricky one. And then just being careful with these 9s and 0s and stuff down here on this one. 9% is 0.09, but 90% is 0.9. I put the 0 there, but it doesn't have to be there. 99.9% is 0.999. And then just remembering your ninths factors, right? 4/9 is all 4s repeating, so it's 44.4 repeating percent. 5/9 is all 5 repeating, etc. As far as for 1/6 goes, I mean, I had it memorized, so I wrote it in the box, but when you get to these ones where you really just can't do it, you can always just grab your calculator. Okay, so I need to figure out what 1/6 is as a percent. Let me do 1 divided by 6, and you get 0.1 followed by repeating 6s, and then you just move that decimal point over 2 spots, 1, 2, and you have 16.6 repeating percent. All right, so let's go ahead and move into a little bit of lesson 2. Lesson 2 is longer than lesson 1, so I think I'll probably do about half of it in this video, and then we'll finish it up tomorrow. So let's see here. Let me flip past lesson 1 here, and lesson 2. So it starts off with just some basic practice on these really simple statements like that were on this worksheet that I did in the video yesterday. These statements like what is 15% of blah, blah, blah. So let's get some more practice of that. My recommendation is that you do these, just always remembering that the word is essentially just means an equal sign, and the word of means to multiply. And then wherever you see what, like with the word what number, what percent, you just use a variable to stand for that unknown thing in the question. And then you solve for the variable using our algebra skills for module 3, and you got your answer. So I'm literally just going to read this sentence piece by piece and rewrite it as an algebraic equation here. 15 is, that means equals, what percent. So I'm going to use a variable to stand for that, but I'm going to remember that when I get my answer here, it's going to be in a decimal or fraction format, and I need to change it to a percent at the end because the question's asking for a percent. And then of 90, so that means times 90. And if I was doing everything conventionally, really this should have been written as 90x, but I'm sort of bending the rules right now and I'm writing it as x times 90. All right, so I want to divide both sides of this by 90 in order to get this answer, to get my x by itself, right? So I would divide by 90 and divide by 90. And so whatever 15 divided by 90 is, that's going to be my percent, but as a decimal. So this is 15 divided by 90. I get 0.16 repeating, but I got to move that decimal point over 2 spots. Oh, okay. So I confused myself for a second. I was like, wait, why does it say whole unit over here? All right. So you know what? The answer to this question is 16.6 repeating percent. But now I realize that that's not even what this activity wanted me to do. This activity here, this is what I get for not reading the instructions. It says, what is the whole unit in each scenario? So they're not even asking us to do all this work yet. They just want us to go through and identify what is the whole in this question, because lots of times that's difficult for students. Just realizing, like, remember all these questions have 3 pieces: the part, the whole, and the percent. And the percent is always relatively easy to identify in each question because it like literally has a percent sign on it. But determining which number you're looking at, is this supposed to be a part of something or the whole of something, that's challenging. The trick that I said the other day in a video that you probably have already forgotten is that the number that follows the word of, let me write this down here. The number after the word of is always, and I'm going to put always in quotation marks just because there'll probably be one time when this isn't true, the whole. And that's because if you're taking a percent of something, right, if that word of is coming before the number, then that sort of implies that that's the thing that's being treated as the whole, because you want a percent of it. So if we use that trick, that actually makes this this exercise of just identifying which number in each question is the whole really easy. What number is 10% of 56? The whole in this case is 56, and you're trying to figure out what part of it is 10%. And so the answer to that one would be 5.6. Okay, 90% of a number is 180. So this one, the thing that came right after the word of, is a number. And so this is a case where we don't know what the whole unit is. The whole in this case is the unknown. They gave us the part, which is the 180, and the percent. Okay, a bag of candy contains, okay, so this of doesn't count, like, because it's not a number following right after it. A bag of candy contains 300 pieces, and 25% of the pieces in the bag are red. Okay, so wait, this one's a little trickier. A bag of candy contains 300 pieces, and 25% of the pieces in the bag are red. Okay, so this is one where like the of trick kind of works but kind of doesn't, because it's not really numbers right after the word of. But if we think about it, it's not too bad. There's 300 pieces in the whole bag, right? And we're trying to figure out what 25% of those, so that would be the part. So I think the whole in this case is the whole 300 in the bag. All right, 70% of the students earned a B on the test. Okay, so, well, if I try to use the of trick, right, looking at the word that's right after the word, the number or the quantity that's right after the word of, it says the students. 70% of the students. And so I think that the whole in this case is like all of the students in the class, which in this case is an unknown again, but we could write that the whole is the students or all students. Either way, it's an unknown. It's like if we were solving this one, we would want to use a variable there. And then the last one says the 20 girls in the class represented 55% of the students in the class. All right, so the 20 girls, I think, are a part of the class. 55% is obviously the percent in this question. So the whole would be how many students are total in the class, or in other words, the students in the class, which follows the word of. So sometimes it's a little weird, and maybe it's not necessarily a number that comes after that word of, but this of rule still kind of worked the whole way, right? Whatever it was that came right after the word of wound up being the whole in the question. All right, so total students in class. All right, so this table here is sort of the same idea, except what it is these are three questions that are almost identical, but with the wording just ever so slightly changed in each one, and it affects which pieces we have and how you would do the question. So in one of these, you get the part and the percent, and the whole is the unknown. In one, you get the percent and the whole, and the part is unknown. And in one, you get I forget what I said, but the other combination. So in each one of these, they give you two different pieces of information and leave one of them out. And they can do that by just ever so slightly changing the wording of the question. And so this is one of those times when I want you to pause the video. I'm pretty sure you can read these words on your screen, or if you can't, use the electronic copy of the book that you're supposed to have open in another tab or another window anytime you're watching these videos. And I want you to read these three questions and try to identify which piece of information did they not give you, the part, the whole, or the percent, and then identify the other two parts, or pieces. I should say pieces because I don't want to say the word part. I think you get what I'm saying. All right, so pause the video, see if you can do this, and then I'll show you. All right, so you should be coming back from a pause. You should have your answers to this table. The first one says 40% of the students on the trip. So the percent is obvious, right? It's 40%. And so now it's just about the other number in there. Is it going to be the part of the whole? If there are 20 students on the field trip, how many love the museum? Okay, so it sounds like there are a total of 20 students on the trip. So that sounds to me like a whole. And the part is what we would be trying to find in this question, right? We'd be trying to figure out what 40% of 20 is. So I'll just put like a question mark in here to represent that that's unknown. All right, the next one says 40% of the students on the field trip love the museum. Okay, so again, the percent is very easy to identify because it has a percent sign on it. If 20 students love the museum, how many are on the trip? Okay, so see how they changed the wording just a little bit. Now the 20 students is actually just a part of how many students are total on the trip, and our job in this question would be to figure out how many total are on there. So in this case, the 20 is the part and the whole is unknown. And then the last one, I think it's pretty obvious that they're not going to give us a percent on this one, right? Because it's like just knowing how this is going to work. This one will be where we have a part and a whole. And it's very tempting to automatically say, oh, 20 will be the part and 40 will be the whole, because part is always smaller than the whole. That's not the case. Remember, I was showing you in another video where sometimes, depending on how the question is worded, the part could actually wind up being the bigger number versus the whole. So let's just be careful and read it and make sure. 20 students on the field trip love the museum. If there are 40 students total on the trip, what percent love the museum? Okay, well, it did turn out that 20 is the part and there's a total of 40 students on the trip, so the whole. So it turned out the way we thought it probably would, but it was still good to check. All right, flipping forward. It says, all right, so now I think this is the first time this book's actually gonna ask us to start answering some of these questions. It says, In Ty's math class, 20% of students earned an A on the test. All right, so what I'm going to do is up here, I'm going to identify the things that the question gives me. It gave me the percent, which is 20%. Right, out of the three things. Every question, there's part, percent, and whole. They're going to give me two of those things. My job is to find the missing one. It says, if there were 30 students in the class, how many got an A? So that sounds like a total or a whole to me. So I'm going to write whole equals 30. And our job is to find the part, the number of students that got an A, which is 20%. So the part equals question mark, unknown. Or actually, no, I'm going to use the variable x, so I should just define that variable now. Part will equal x. Okay, so the question essentially then is, if I rewrite it in simpler terms, like not caring about Ty and his math class and grades of A or whatever, just in a strictly numerical sense, the question is, what number, sorry, the curl of the book is making my handwriting all bad. What number is 20% of 30? That's what this question's really asking. If you forget about the Ty and his math class and the grades and stuff. And now, using the fact that is means equals and of means times, and wherever I see what, that's where I'm going to put a variable, I can just turn this into an algebraic equation. What number, okay, so x is, that means equals 20%, so that's 0.20 of 30 times 30. Now I'll get my part, or my unknown, if I just do 0.20 times 30. So I'm going to show you how I could do that on a calculator. I mean, 0.2 times 30. Okay, it comes out to 6. But I'm also going to show you how you could have done that like in your head or just with a little bit of scratch work. So I'm thinking I want to do 3 times 2, which is 6. But really I have 30 here. So it's 30 times 2, which is 60. But here I have this decimal is one space behind the decimal point. And so this 0 and the fact that this decimal point, this number is one behind the decimal, essentially cancel each other out and give me 6. Another way to think of it is that 0.20, that's the same thing as 1/5. And so they're asking you what is 1/5 of 30, or what is 30 divided by 5. That might be another way to think about the fact that the answer is 6. Or if you like doing this little side work over here, you could go 30 times 0.2. And then if you're just keeping track of your decimal places really well, right, you're going to get a bunch of zeros, 0, 0, 6. And then you just think, okay, I've got 1, 2 numbers behind the decimal place. So 1, 2, the decimal goes here. That's probably the way your second grade teacher or whatever taught you how to do it. All right, so we got asked a question in words, so we answer it in words. We say 6 students got A's on the test. All right, let's do one more, and then we'll call that enough for this video. How about you pause it and try to do this one before I show you? It's this one about Ty's art class, 12% of the projects receiving a perfect score. Here, actually, I'll read it for you. It says, in Ty's art class, 12% of the Flag Day art projects received a perfect score. There were 25 art projects turned in by Ty's class. How many of the art projects earned a perfect score? And they're telling you to identify the whole. So they're giving you a hint that of the three things, 3 parts of the question, the one that they didn't give you is the whole. These are often considered the trickiest and weirdest of these questions. All right, so you pause it, do your best to try to answer it, and then you'll see my answer when you unpause. All right, so let's see here. Over here, I'm gonna identify the pieces that the question gave me. It told me that the percent is 12%. And then it says that 25 of the projects turned in. Oh, you know what? I misunderstood what they were putting here. I hope this didn't mess you up while you were trying to answer the question. When I read this and it said identify the whole, I thought that that was the question's way of telling us that the whole was the missing piece of information in this question, but it's actually not. They've given us the whole in the question. I guess they just wanted us to identify it first before we answer the question. That's weird. I wish you didn't even say that. It messed me up. Whatever though. So the whole is the total 25 art projects that were turned in. And then our job is to figure out the part, which would be the 12% that got perfect scores, right? And that's the unknown, so I'm going to call it X. And so this one winds up being exactly the same as up here, right? In the previous one, we got the percent, the whole, and we had to find the part. And this one, same thing. We got the percent and the whole, we got to find the part. So if we think of it again as this sentence, what number is 12% of 25, then that translates to the algebraic equation. What number, x, is equals 12%, 0.125 of, that means times 25. And let's just use the calculator on this one. So we're doing 0.12 times 25, 0.12, 2 times 25, 3. Looks like 3 students received perfect scores. And we write that conclusion. All right, I think that's good enough for today. We'll finish the rest of lesson 2 in the next video.